Welcome to This Explainer. Today, we're skipping the basic 101 stuff. We all work in an industry that claims to be agile, right? But let's be real, so many teams fundamentally fail to understand the deep mechanical differences between the actual frameworks that power it, specifically extreme programming and Scrum. In this detailed breakdown, we're going to bypass all those generic buzzwords. We're going to deeply analyze the actual engineering rigor and the process management tactics that separate these methodologies so you can really understand exactly how they function under the hood.
So, to ground our technical analysis, let's briefly recall the core problem we're trying to solve. Imagine building a house and then deciding, you know what, let's move the master bathroom completely, after the concrete foundation is already poured. It's a disaster. But more accurately for software engineering, imagine having to completely refactor a deeply embedded legacy database schema super late in the development cycle just because a key stakeholder changed their mind. Trying to predict shifting customer requirements months in advance, it's just a recipe for architectural disaster. Conventional waterfall processes try to lock in that design up front, and that leads to skyrocketing technical debt and catastrophic costs when market priorities inevitably shift.
So here is our roadmap for today to see how we solve this. First, welcome to Agile development, then extreme programming basics, and XP's core engineering practices. After that, we'll hit the Scrum framework explained, Scrum roles and ceremonies, and finally, Scrum versus extreme programming. Let's get right to it.
Starting off with Section 1, Welcome to Agile Development, Embracing the Chaos. Let's establish the foundational math behind why these methodologies actually work. Think about the cost of change over time. Conventional software processes suffer from an exponential cost of change curve. As the development schedule progresses, adapting your codebase becomes astronomically expensive, mostly because you're fighting against this rigid, monolithic architecture. Well, Agile methodologies fundamentally flatten that curve. They mathematically reduce the cost of pivoting by interleaving the design and the construction rather than isolating them into separate phases. You don't try to predict the entire system architecture up front. Instead, you build a small increment, you test it, you get feedback, and you adapt. That keeps the structural rigidity and therefore the cost of changing it as low as possible throughout the entire project lifecycle. Now, to keep those costs permanently low, the continuous delivery of working software is completely non-negotiable. But the absolute linchpin, the thing that actually makes this flattened curve possible, is daily collaboration between the business side and the developers. Think about it. If you're delivering software in 2-week cycles, but getting feedback from the business takes 3 weeks, your cost of change immediately stacks right back up. Agile structurally demands that business stakeholders are deeply integrated into the daily workflow. That turns volatile, late-stage requirement changes into a strategic competitive advantage, rather than a critical system failure. That brings us to Section 2, Extreme Programming Basics, the Engineering Obsession. We're going to look at exactly how to technically implement these principles. Extreme programming, or XP, is arguably the most disciplined, opinionated engineering toolkit in the entire Agile landscape. The XP iteration loop operates on this relentless cycle of continuous feedback. It starts by taking broad requirements and pushing them through rigorous release planning. From there, the team moves into really tight 1 to 2 week iteration cycles, writing code, running automated tests, and immediately seeking acceptance testing from the customer. The mechanics here are crucial. XP absolutely refuses to let developers build in a vacuum. Every single iteration must result in a small release that is explicitly approved by the customer before moving forward. Within this loop, requirements aren't handed down as these massive, highly technical spec documents. Instead, XP strictly leverages user stories. Now, for an experienced team, a user story isn't just a simplified spec. It actually acts as a placeholder for future conversation. By completely excluding the finer technical details and edge cases, it prevents developers from over-engineering solutions prematurely. Basically, a user story is a promise that the developer and the customer will physically sit down together and negotiate the exact business value right before the code is actually written. So how do you keep the architecture coherent without heavy upfront design? XP utilizes what they call a metaphor. This is a rapid, common vision of how the system should operate. For instance, if you're building a highly complex asynchronous data routing architecture, the team might use the metaphor of a post office to describe how data packets are sorted and delivered. It's brilliant because it gives every single engineer a shared, intuitive blueprint to reference when naming classes, structuring modules, or discussing system interactions, all without needing a 100-page UML diagram. But inevitably, developers are going to hit a technical unknown.
right? Maybe a brand new third-party API or some unproven database query optimization. When this happens, XP dictates the creation of a spike. A spike is a strictly time-boxed rapid prototype used purely to validate a technical hypothesis. Crucially, though, the mechanics of a spike demand that the code is thrown away immediately after the experiment concludes. Literally, toss it. This ensures that quick, dirty, experimental code never accidentally pollutes the production codebase, which protects the integrity of your main branch. Let's explore the tactical rules a bit deeper in Section 3, XP's core engineering practices, discipline meets flexibility. In XP, these practices are entirely non-negotiable. Take pair programming, for instance. It isn't just about two developers awkwardly sharing a single keyboard. It effectively replaces traditional asynchronous code reviews with continuous, synchronous peer review. That drastically reduces defect rates. Similarly, collective code ownership dictates that absolutely no single developer owns a specific file or module. This systematically eliminates single points of failure in the team's knowledge base, what we often call the bus factor, meaning anyone can step in, refactor, and deploy any part of the system at any time. And here is the absolute crown jewel of XP, test-driven development, operating on that strict red-green refactor cadence. TDD is often misunderstood as just a quality assurance practice, but actually it's a core design activity. By forcing developers to write a failing test first, they have to think entirely about the interface and the desired behavior before they even touch the implementation. You write the failing test, you write the absolute minimal code to make it pass, and then you refactor. This guarantees continuous correct behavior, sure, but more importantly, it naturally drives the architecture toward highly cohesive, loosely coupled modular code. Shifting gears from deep engineering to project management, we arrive at Section 4, the Scrum Framework Explained, Process and Management. So, unlike XP, Scrum operates as a lightweight management wrapper. The Scrum workflow relies on a continuous, tightly controlled cadence. It begins with the product backlog, that's the master list of the what, which is prioritized strictly by business value. The team then pulls a realistic subset of those items into the sprint backlog, which dictates the how. Now, for the duration of that 1 to 4 week sprint, those goals are fiercely protected. The scope cannot be arbitrarily changed by outside stakeholders. Period. This gives the development team the focused, uninterrupted execution time they need to actually produce a potentially shippable product. To manage all this flow, Scrum relies on 3 core artifacts, ending always in the increment. The absolute critical component here is the definition of done. And listen, this isn't some vague milestone. In a mature Scrum team, done means the code is peer-reviewed, it's passed through all automated CI/CD pipelines, it's fully documented, and it's deployed to a staging environment. It means there is absolutely zero unverified work, zero technical debt, and zero QA testing left for a later date. If it doesn't meet the definition of done, it does not become part of the increment. No exceptions. To enforce these strict rules, we move to Section 5, Scrum Roles and Ceremonies, Who and When. Scrum systematically takes the traditional project manager role and replaces it with this dynamic tension between 3 specific roles. First, the product owner pushes for the business needs, dictating what gets built and when to maximize ROI. Then you have the development team, a self-organizing, multidisciplinary unit that dictates exactly how the work gets executed and how much they can realistically handle. Finally, the Scrum Master acts as the referee. They're a servant leader whose sole focus is to remove blockers, facilitate the ceremonies, and protect the process, ensuring that neither the product owner nor the developers violate the rules of the framework. To keep everyone perfectly synchronized, Scrum replaces ad hoc, messy meetings with 5 strict, time-boxed ceremonies. You have the sprint itself, which is initiated by sprint planning to define the scope. Every 24 hours, you do a 15-minute daily scrum to align the team's immediate tactical execution. Then, at the end of the cycle, there's a really vital distinction between the final 2 meetings. The sprint review is focused entirely on inspecting the product increment outward with stakeholders. Meanwhile, the sprint retrospective is an inward-facing meeting where the team inspects their own processes, identifying bottlenecks to continuously improve their efficiency for the very next cycle. And that brings us to our final analysis in Section 6, Scrum versus Extreme Programming, the ultimate showdown. The core thesis of everything we've talked about today is understanding the fundamental contrast between these 2 approaches. Scrum is an agnostic management wrapper. It operates in 1 to 4 week sprints to control complex delivery flow, but it remains entirely silent on how you actually write the software. It leaves the engineering practices completely up to the team. Extreme programming, on the flip side, is a deeply opinionated engineering toolkit. It operates in much tighter 1 to 2 week iterations and rigidly enforces how code is written, mandating test-driven development, pair programming, and continuous integration as unbreakable laws.
So as you take this analysis back to your own architecture and workflows today, I want you to closely examine your current bottlenecks. Are your deployments failing due to spaghetti code and massive technical debt? Well, if so, you probably need the strict non-negotiable engineering mechanics of extreme programming. Or is your team writing great code, but you're constantly missing deadlines due to scope creep and poor stakeholder alignment? In that case, you definitely need the rigid process boundaries and transparent roles of Scrum. And remember, these two aren't mutually exclusive. The most mature software teams use Scrum to manage the outward flow and XP to enforce the engineering rigor inside the sprint. Keep analyzing, keep iterating, and thanks for joining me on this explainer. See you next time.